So here are some trig limits that we're going to look at. Let's just first review the critical trig limits that you must already know. The limit as theta approaches 0 of the sine of theta over theta is equal to 1. Likewise, the limit as theta approaches 0 of theta over sine theta equals 1. And the limit as theta approaches 0 of 1 minus cosine theta over theta equals 0, where this limit does not exist. Theta over 1 minus cosine theta does not exist. The reason that these two are the same is because if you take the reciprocal of theta over sine over theta, you get 1. So therefore these two are equivalent. However, if you take reciprocal of 0, you get a 0 in the denominator, so it's undefined. So that's why this limit doesn't exist. So this is of no help. So in order for this statement to be true, you need to be taking the sine of an angle and dividing by the same exact angle, which in this case I'm taking the sine of 5 theta, so therefore I'm dividing by 5 theta. So therefore the limit of this is just 1. Since these two angles are the same, this limit is 1. You're done. This one is the limit. We can't use this basic limit here because we have 3 theta and theta down here. These two angles need to be the same. So I need to put a 3 right here. So I just squeezed in a 3. Well, since I put a 3 there, I must use the property of 1 and squeeze in a 3 up top. So now I have our desired limit, sine theta over theta, which is pretty much the only limit we're going to use all day. Sine 3 theta over 3 theta is equal to 1, and there's a 3 in front, so therefore it's 3 times 1, which is equal to 3. Number 3, this 4 is really of no consequence. I can just peel that off and say that limit is 1, multiply it by 4, I get 4. Here this 7 is kind of annoying. We want a 5 theta to be up here, not 7 theta. So I just got to move this 7 out of the way, squeeze in a 5, use the property of 1, and then I'm all set. So let's just rewrite it. I'm just going to put the 7 up front and do sine 5 theta and theta. So therefore I need a 5 here. So now this limit right here is going to be 1. I need to use the property of 1, so I'm just going to balance that 5 that I put with another 5 over here. So therefore I haven't changed the problem, but I've changed its look so that I can take the limit. This limit is equal to 1. This is 7/5, so my limit is 7 over 5. Here's two sines. Again, our basic limit is sine theta over theta is equal to 1, or the reciprocal. So let's just rewrite this. Typically what I do is I just write it as two separate fractions. So I do sine 3 theta times sine 5 theta. So there's a theta down here. I'm in good shape. Using the property of 1, I need to have a theta up here, but conveniently, I need that theta to match up with this sine 5 theta. So now, I need a 3 to match up with this 3, so I'm going to put a 3 here. I'm going to write a 3 on the outside over here. And a little, where to have blue. And then I need a 5 for this limit to work, so I put a 5 here. I'm going to squeeze a 5 up front. So now I have these two sine limits are both 1, and that's 3/5, so my limit is 3/5. Again, like the most popular limit is, in this case, sine x over x. So I'm going to rewrite it as the sine of x over x. So if I take a sine out of this, I'm left with a sine. And if I take an x out of this, I'm left with a 2. Well, this limit is equal to 1. And this one I can just do direct substitution. I just can plug in 0. So I get the sine of 0 over 2, which is 0 over 2, which is equal to 0. Before we tackle number 7, I'm just going to do a brief fraction review. Is if I have 5 over 7 plus 9 over 7. This is equal to 5 plus 9 over 7, which is equal to 14 over 7. And I know that's 2, but I don't really want to write that as 2. Well, I could, doesn't really matter. I think the rule that everybody knows is that everybody can go from left to right. As long as the denominators are the same, you can add the numerators and rewrite it like this. Though nobody would write down 5 plus 9, you would just do 5 plus 9 in your head and do 14 and write it down as 2. What I'm interested in is just this piece right here. Again, everybody's comfortable going from left to right in this case. Well, what about going from right to left? Well, it works just the same. As long as you have one denominator and you have a binomial, meaning 2 terms in the numerator, you can write it as 2 separate fractions. So I'm just using simple fraction addition with common denominators backwards. So in this case, I'm going to write this as 2 separate fractions over x. So as x approaches 0, 2x over x minus the sine of x over x. Conveniently, these two x's cancel out. So that gives me 2 minus the sine of x over x. Well, plug in 0 into this. Well, there's no x here, so it's just 2. Plug 0 into this, you just get 2. Plug 0 into this, you get 1. So 2 minus 1 is 1. Number 8. This denominator is kind of bothering me, so I'm going to rewrite that denominator. Obviously by factoring, that's all I can really do to it. Take out an x, I get x minus 2. Voila, here's our magic limit, sine of x over x. So let's just rewrite it as 2 fractions being multiplied by each other. The sine of x over x times 1 over x minus 2. This limit right here is equal to 1. And if I just plug 0 in here, I get negative 2. So this is 1 times 1 over negative 2, which is negative a half. This one you would like to think that you could use that limit from above, which is the limit as theta approaches 0 of theta over 1 minus cosine theta times theta. Well, since I can't take the reciprocal of 1 minus cosine over theta, or I can't write it like this because then this limit is undefined, this doesn't really help me. So we have to use an alternative method. And here's a classic problem. This is magically going to turn back into sine theta over theta. I'm going to multiply this by the conjugate, which is 1 plus cosine theta, 1 plus cosine theta. So this is theta squared, 1 plus cosine theta, all over. I'm going to multiply these two. It's a conjugate, so there's no middle term. So 1 minus cosine squared theta. What's convenient is 1 minus cosine squared, hopefully you know, is sine squared. So this is theta squared, 1 plus cosine theta, all over sine squared theta. Well, this is one of our magic limits. So let's just rewrite it so it's easier to see. It's theta over sine theta times theta over sine theta times 1 plus cosine theta. Well, this limit is 1, and notice that theta times theta is sine squared. Theta times theta is theta squared. Sine times sine is sine squared, and 1 plus cosine just goes on the outside. So this limit is 1, this limit is 1, and if I plug in 0 here, I get 1 plus 1. So this is 1 times 1 times 1 plus 1, which is equal to 2. Our last limit that we're going to look at here is I'm just going to rewrite this. Hopefully you all know that cosecant is 1 over sine. So theta times 1 over sine, which is equivalent to theta over sine theta, and magic. There's our limit. Okay, that's the way. I got another video of trig limits coming up. Hope you enjoyed it.